Hi ladies, it's Mr. O'Sullivan. Today we're looking at lesson 3-3, Introduction to Angles. Just a heads up, today is an Edpuzzle lesson, so you'll be interacting with the video and taking notes on your own sheet of paper. Today's learning target is, I can understand the basic properties of angles in geometry. So today all we're doing is looking at angles. There's not really much math going on. Before we go into what angles are, we need to know what the definition of an angle is. An angle is simply the union of two rays that have a common endpoint. So when I say ray, I basically mean something like this. So for instance, let's pretend we have ray AB. Rays are something in math that start and then they just go on forever and ever and ever. So if I wanted to, I can write ray AB as this, which is sort of like a vector. But the thing is, we're saying that this angle will have a common endpoint. Also, by the way, I am a little under the weather still, as you know from this past week, so if I sound nasally or any of that stuff, it's just because I'm still not feeling that great. Now, since I'm saying that they have that common endpoint, I can make another ray. And if I wanted to, I could maybe say maybe make ray BC, or even AC. That's what I'm going to do. I'm going to make ray AC. So I start at A and then end at C. If you look, this is exactly an angle. It's opening up and I can find out what the value of that angle is. I mean, right now it looks like it's definitely not that large because of this very tiny opening. So maybe we can classify that later on. So now there are parts of an angle. Basically anything outside of your opening, so like all this gray area right here, is called our exterior. Our angles also have sides. For instance, this side would be BA and this side would be BC. Our vertex is where the two sides meet. So in this case, our vertex is B. And then our interior is basically anything on the inside of your angle. So this is all the interior. Now there are 4 ways to name this angle to the left. We can name it using letters, we can name it using numbers, or we can name it just using one letter. I'm going to name it using letters first. So if you look, I can tell that this is my angle right here where I'm opening. So I can start at A, go to B, and end at C. So I can say I have angle A, B, C. If you look, I can also start at C, go to B, and then end at A. So I can say I have angle C, B, A. If you also look, I could just name it angle B using one letter. Or what we're going to typically do is we can just put a number here. We're not saying that this is 1 degree. We're just saying that this is angle 1. So now let's go into some definitions of angles. An acute angle, that's any angle that's less than 90 degrees. So for instance, if your angle is 30 degrees, 45 degrees, 72 degrees, those are examples of acute angles. A right angle is an angle that's equal to 90 degrees. So anytime you have a 90-degree angle, that's a right angle. An obtuse angle is an angle that is larger than 90 but less than 180. So for instance, 91 degrees, 98 degrees, 131 degrees, those are all examples of obtuse angles. A straight angle is simply an angle that's 180 degrees. So I'm going to go to this image right here, and I can see that I have a straight line that's a 180 degree angle. And then a reflex angle is basically an angle that's larger than 180. It's like 181, 195, 270. Those are examples of reflex angles. Question, what is 2/3 of a right angle? So when I ask you what 2/3 of a right angle is, well, we know a right angle is exactly 90 degrees. So what I'm really asking is, what is 2/3 of 90? So I type that into my calculator, or I can just do it in my head. 2 times 90 is 180. 180 divided by 3 is 60. So I get 60 degrees. So 2/3 of a right angle is 60 degrees. Classify 2/5 of a straight angle as acute, right, or obtuse. Well, we know a straight angle is 180 degrees. So I'm going to do 2/5 times 180. Well, let's do it. 2/5 times 180. That will give me a 72-degree angle. Now I have to ask myself, is 72 smaller than 90, equal to 90, or larger than 90? Well, it's smaller than 90. So I can say that this is an acute angle. Name the angle to the right as many ways as possible. If you look, I can name it using 3 letters. So I can start at P, go to Q, end at R. So I have angle PQR. I can also start at R, go to Q, end at P. So I have angle RQP. I can also just go to my vertex and say angle Q. Or if I want, I can put like a 1 here and just call it angle 1. Now my vertex would simply just be Q. My sides are QP and QR. Now these are some independent question practices, independent question practice from the Edpuzzle. So answer each of the following best to your ability. Classify each angle as acute, obtuse, right, or straight. So if I have a 162-degree angle, that's larger than 90 and smaller than 180, so I can say that this is an obtuse angle. If I have a 74-degree angle, that's smaller than 90, so I can say that this is an acute angle. 180 degrees, well, we know that that's a straight angle. And then half of a right angle. So for this one, I do 1/2 times 90, which is 45 degrees, which is an acute angle. And then we're going to name this angle in 4 different ways, 1 point for each way. I start at E, go to D, end at C, so I can say angle EDC. I can also say angle CDE. I can also just say angle D, or I can say angle 2. And that's it for today. Don't forget to start working on weekly homework number 2.